All right, so here we are with exercises 3 and 4. Remember, you really got to do these first to get the most out of it. And if you're struggling to do it, make sure you're making guesses. Don't just get stuck and give up with these problems. You can make some guesses at some random binomials, like, it's going to be 2x and x times something. Just try some stuff here. If it's not working out, then that's okay. But if you haven't done a bunch of guesses for these yet, then do that first and come back. And by the way, exercise 4 is a challenge problem, which means it's kind of optional. If you're struggling, you can skip that if you want. But if you want to get like an A in the class, you should definitely do challenge problems. Okay, anyway, so let's look at the solutions for exercise 3 here. So for this one first, there's no common factors. So what we're going to do is the 2 times -6 is -12. We want two numbers that multiply to make -12. And they need to add up to 1, because the coefficient of x here is 1. So what will work there is, let's see, 4 plus -3. Those multiply to make -12 and add up to +1. So I'm going to rewrite this as 2x squared plus 4x minus 3x minus 6. And then we've got these two groups we can factor by grouping. The first group has a factor of 2x. And then, let's see, there's going to be an x plus 2 left over. 2x times x is 2x squared. 2x times 2 is 4x. Then over here, these have a common factor of -3. And then there's going to be an -3 times x is -3x. And then -3 times +2 is -6. So yay, that works out. So these two big terms now each have a factor of x plus 2. So that's going to turn this into 2x minus 3 times that x plus 2 part. And it's a good idea to FOIL this out. Make sure it works. You're going to get 2x times x is 2x squared minus 3 times x plus 4x. And then -3 times 2 is -6. So that works. All right, now let's look at this one. Let's see. First, is there a common factor? Well, let's see. Oh wait, they're all even numbers, so you could take out a 2. And then you might notice, oh wait, they're all multiples of 4, so you can take out a 4. So you can take out a common factor. 4 times, let's see, 3x squared makes 12x squared. 4 times -11x is -44x. And 4 times 6 is 24. So that's how that works out. Then let's see. So this is why when I said this first step here, factor out all common factors, there are going to be situations where there's common factors, and it's really important to do that first, because otherwise the A and the C we'd be doing would be 12 times 24, which is like 288, and 288 has a ton of different factors. It would be really hard to do this without taking out the 4 first. All right, so the A times C, now that we're using 3 and 6, is not that bad. 3 times 6 is 18, and we want two numbers that multiply to make 18 and add up to -11. So we could think about that for a bit. How about -9 and -2? That works. So I'm just going to rewrite this with the 3x squared minus 9x minus 2x plus 6. Those add up to make that -11x there. Okay. So now we have a group on the left and a group here. So I can write it as 4 times, let's see, the group over here has a factor of 3x. Let's see what's left over after you take out 3x. 3x times x is x squared. 3x times negative 3 is negative 9x, so that works. And then we're going to have a, let's see, 2x and 6. Those both have a 2 in them, so I can write this as plus 2 times negative x plus 3. That works, but wait, these two things aren't the same. Oh no. I can't factor this by grouping. If one group has a x minus 3 factor and the other group has a negative x plus 3 factor, so the trick is, instead of taking out a 2, what if you just take out a negative 2? That would look like this. Then these are the same. We have an x minus 3 and an x minus 3, because negative 2 times x is the same as negative 2x. Negative 2 times negative 3 is the same as 6. So that works out. So now these two big terms have a factor of x minus 3. So I'm still leaving the 4 alone here. There is a 3x minus 2 and an x minus 3. And there's still these parentheses on the outside, but if you want to ignore those, that's okay, because as long as you have 3 things being multiplied here, you could regroup the parentheses however you want, so those don't really matter. So that's your answer, and of course it's a good idea to FOIL it all out and check. If you want, you could distribute the 4 in first. That might make it easier. So you get 12x minus 8, and then times x minus 3, and then 12x times x is 12x squared. 12x times negative 3 is negative 36x. Negative 8 times x is minus 8x. Negative 8 times negative 3 is plus 24. And negative 36x minus 8x does work out to negative 40x, and everything else is the same, so that looks good. Okay, exercise 4 here is a challenge. If you skip this, I don't blame you, but if you're trying to do the absolute best you can and you have time and you like a challenge, these are a good thing to do. So the trick here with this one, when you have p to the fourth power is what you get by doing p squared times p squared. These two come out to be p to the 4th. And so these other numbers here are going to need to be things that multiply to make negative 2. And then they need to be added up to make 1. So what multiplies to make negative 2 and adds up to 1? How about 2 times negative 1? That will work, and that's the answer. And actually, so if you write this as your answer and you put a box around this, that's okay. But p squared minus 1, I'm just going to rewrite this as minus 1 here. P squared minus 1 can be factored, because what happens if you have something that looks like a squared minus b squared? Because p squared is p squared, 1 is 1 squared. That, if you look at the factoring rules above, can always be factored into the form a plus b times a minus b. These are those important rules that you're going to need to eventually memorize that are in the box. This is called a difference of squares. So you can do the same thing here with the p squared minus 1. So there's still p squared plus 2. Turns out that can't be factored. But the p squared minus 1 part can be turned into p plus 1 times p minus 1. So that is now completely factored. So if you got that, give yourself an extra large pat on the back. That's really good. Okay. Wait, that's not what I meant. The key, there's the key to the city for you. I don't know why I have a key icon in my keyboard shortcuts, but I do. All right, whatever. Let's go on to this one. The trick with this one is this looks like a squared, or sorry, we were calling it x and r. Well, I'm gonna call it a and b. Okay, so a squared plus 2 times a times b plus b squared. So the a in this case is r plus 1. The b is 36t. And if I write this again with r plus 1 squared, and instead of writing, like, I want to have it in the form 2 times a times b, I need to have that 2 there. And then we can see if the a and the b line up with everything else. So the a would be 6t. So 2 times 6t makes 12t. The b would be, oh, I got that backwards. Whoops. I already know the a is r plus 1. The b, well, let's see, what do you square to get 36t? That would be 6t. So I'm going to write this as 6t quantity squared now. So sorry, 36t is not b. B is actually 6t, because when you square all of the product 6t, that gives you 36 times t squared. Okay, so this is in that form. So if you remember the formula here, this is the result of doing a plus b squared. So let's see. That's the way we're going to write this. Is r plus 1 plus b, in these parentheses is going to be plus 6t, and all of that squared. And that is actually the right answer to that. So if you got that, that's a pretty difficult one. All right, so that's those exercises. I'll do the next examples where we start solving equations in the next video.